Hey folks, it's your man, Jacob Kempe, coming at you with the news. Today, we're going to start with a segment called the integrity system and you. Hey people of Miss Bird's classroom. So, you want to learn about the integrity system and how it has an effect on you? Oh, well you're in luck. I'm here to tell you about it. First of all, let's do an experience. This takes 2 people, so grab a partner or don't, I don't care. First of all, make a fist with your hand. Hit your partner. That hurt, didn't it? That's because the pain receptors in your dermis. Pain receptors send pain signals to your head to tell you when your body needs to be taken care of. You know what else is an important part of the integrity system? Sweat. You know, that stuff that smells bad and happens when you have to socialize. This is because your body is trying to regulate your body temperature. When you overheat, your body tries to put out a watery substance that conducts the heat from your body out. The integrity system also affects your skin color by making melanin to protect you from UV rays. You may notice some dots in your body called moles that are darker because they produce more melanin. Next we have a segment called the cell cycle. In this cell cycle, the cell is mostly in the interphase where it's not dividing. There are 3 stages in the interphase. G1, where the cell grows, followed by the S phase, where the cell replicates its DNA. Then, in G2 phase, the cell makes last preparations for mitosis. It has to go through checkpoints to make sure it's ready for mitosis. First checkpoint is at G1 to make sure the cell is big enough and has enough proteins. After G1 checkpoint, the cell goes through DNA synthesis in G2 phase, and it reaches the G2 checkpoint to make sure all the DNA has been copied and no DNA is damaged. The M checkpoint happens at the end of karyokinesis and determines if the sister chromatids have attached to their spindles. Now let's talk about cancer and the cell cycle and how the body tries to prevent it. Pro-oncogenes are genes coded for the positive cell cycle regulators. If these genes are mutated, they become oncogenes, and oncogenes are genes that cause cells to become cancerous. The mutation might get caught by checkpoints and will not grow anymore, but in some cases, it will pass through the checkpoints and become cancer. Another thing special about the cell cycle, if it finds a damaged chromosome, the cell will commit suicide, or apoptosis. Sometimes apoptosis happens for other reasons, like there are too many cells, or the cells are no longer needed. Another thing that helps damage DNA is tumor suppressor genes that have a special protein to look for DNA that is damaged and can stop cells from dividing. If the cells have DNAs mutated and has damaged chromosomes that pass through checkpoints, it will keep dividing and making more cells that have the DNA to ignore the checkpoints. That would be cancer. First type, we're going to talk about basal cell carcinoma, which is the least serious but most common skin cancer. It is found in the deepest part of the epidermis, where the basal cells are found. It usually looks like scars, red spots, or shiny bumps. You get basal cell carcinoma from exposure to UV light, like the sun, or more likely, tanning beds. It happens the most on exposed parts of the skin, like the face, and is more common for people who live down south. Next we have squamous cell carcinoma, which is not serious if treated early, but is the second most common skin cancer. It can be found in the epidermis, like the basal cell carcinoma. They look red, lumpy, and scaly, with rashes and ulcers. This cancer can be aggressive and go to other parts of the body and cause real problems if not dealt with early enough. You get this cancer from prolonged exposure to UV light, like the sun and tanning beds. It mostly affects exposed skin, like your face, and is more likely for people down south, just like basal cell carcinoma. Last but most dangerous is melanoma. It is the least common but extremely serious. This cancer is found in melanocytes, in the basal cells of the epidermis, that forms a malignant tumor. They look like moles, or come from moles, being skin-colored, red, brown, pink, blue, or white, and are oddly shaped with abnormal borders and are unusually big. It is caused by intense and occasional UV light exposure, like sunburns. Thank you for your time today. Hope you had a blast listening to the news, like I did. Good night, goodbye, see you later.